let me open up a new script. Okay. So I opened up a new script. Your new script could be either locked in or docked in to your MATLAB, or you can undock it. See this right here? Undock, and it will be outside of your MATLAB right now. It's a matter of preference whether you want it to be in there or you want it to be outside. Now let's go to the concept of loops. With loops, we have two kind of loops in MATLAB: for loop and while loop. For for loop, what you say is for I from 1 to 5 display I. End. Let's see what this does. For I from 1 to 5, so you have a counter first of all. It starts somewhere from 1, for example, goes to somewhere 5, for example. Display I. So what it does is I is set as equal to 1. Then all these commands will be executed. So display I is 1, so display 1. And then end, because all the commands are executed. End. When it is end, goes back. For I was 1 before, now I becomes 2. Now it will execute all these commands. So 2 will be displayed. End. Go back. I is now 3. 3 will be displayed. End. I is now 4. 4 is displayed. End. I is now 5. 5 is displayed. End. I becomes 6. 6 is more than your maximum set number. So that's when the loop will break. The loop will end there. Does it make sense? So why don't you execute this and see what happens? Maybe open up a new script and do that. For I equal to 1 through 5, display I end. 1, 2, 3, 4, 5 are shown on the screen for me when I execute those commands. One point here that might be confusing, but still it's worth discussing, is that remember before when we had display, we had apostrophes, we had strings. You can still have a string if you want, but if you put I as a string, I will not be changing. Right? As a string, I is I. That's it. Let's try it. If I put apostrophe here and here, I am setting I. I is not a value anymore. I is a character. So it will just display I 5 times on the screen for me. Does it make sense? So if you have apostrophe, I is going to be a character, and that's it. It doesn't have a value, it's a character. If you don't put it there, I is basically this I, which has a value. 1, 2, 3, 4, 5. Is it clear? In the back, everyone is clear?
Why does it display it 5 times?
Because 1, 2, 3, 4, 5. See this counter?
So, Okay, so it counts each individual time regardless?
Yeah, so what happens is that I becomes 1, it will display character I, done. I becomes 2, it will display character I, done. I becomes 3, display character I, all the way to 5, so 5 times.
Okay.
Does it make sense? Perfect. So that was the for loop. And then we can use the for loops to calculate the summation of all the elements within a vector. You might ask, we can use the function sum. Why do we want to do that? And you're right. It's just for the purpose of understanding how the for loops work. We are going to do it. So let's say x. We have a vector x, which is 1, 3, 4, 8. I want to calculate the summation of all the elements in vector x. So when we want to use a for loop to calculate the summation, what are we going to do? We are going to put the summation, we are going to set the sum of all elements, let's say sum x, because we don't want to use we don't want to use sum as a variable name, right? Sum is a built-in function, we don't want to use that. Sum x is equal to 0 because 0 is a neutral value for summation, right? So if you start at 0, anything that's added to it, that 0 doesn't have an impact, right? So start at 0, then you would add the first element. So it becomes sum x. Let's put sum x as 0. Then we can add the first element to this. Sum x becomes what? 0 plus 1 becomes 1. Then we can add the second element to this. Sum x was 1, now becomes 1 plus 3 becomes 4. Then we can add the third element to this. Sum x previously was what? 4 plus 4 becomes 8. And now we can add the last element to this. Sum x is equal to 8 plus 8, 16. Right? So that's the summation of all the elements in vector x. Now let's see how we can write this as a for loop. Why don't you do this? Why don't I give you some time to think about how you can write this algorithm? Can you see it in the first place? Can you see the algorithm from here? Maybe? A little bit? Let me give it, or turn on the light here. Is it better? No?
Yeah.
So what happens is that you set sum x equal to 0 first. And then in a for loop, you will start adding elements to sum x. So sum x is equal to sum x plus x of 1. Sum x is equal to sum x plus x of 2.
Are you asking us to write that in, or are you asking us to figure out a way to say for?
Figure out a way to use for loop to solve that. Think about it. Think how you can write this as a for loop. In any case, you have sum x equal to 0. That's the starting point, right? So that's the starting point. From there on, you will have a for loop. For I from 1 to what? How many elements do you have in x? 4. From 1 to 4, sum x is equal to sum x plus x of 5. All right, let's have a look here. I wanted you to have an exposure and think a little bit how we can put it in for loop. Now let's do it together. So first thing first, CLC and clear, get rid of everything that was there before. Then let me define my vector x, which is 1, 3, 4, 8. 1, 3, 4, 8. Then the neutral value for addition is 0, because 0 doesn't have an impact on the summation, right? 0 plus anything is whatever it is. 0 doesn't have an impact. What is the neutral value for multiplication? 1, right? So 1 times anything is whatever that value is. 1 doesn't have an impact. So neutral value for addition is summation is 0. For multiplication is 1. So I define sum x as 0. Now what I want to do is I want to take each element in x and add them to sum x, right? That's how we can calculate the summation of all elements. We can take the one element or each element in x and add them to sum x. So basically I'll need a for loop for I from 1. So from the first element till the last element you should loop, right? How many elements do you have here? 4 elements. So from 1 to 4, sum x is equal to sum x plus x of I. End. Let's see how it works. Do you see it, or should I turn off the lights here, or is it clear? It's good. Let's see how it works. So it will set sum x equal to 0 right here, and then I becomes 1. Sum x is equal to sum x. What was sum x? Was 0. Plus x of y. X of 1, the first element in 1 is what? 1. So 0 plus 1 becomes sum x. Now sum x is 1. Goes to end. I becomes now 2. Sum x was what? 1. X of 2 is what? 3. 1 plus 3 becomes 4. So sum x is now 4. And I becomes 3. Sum x was 4. The third element in the x is what? 4. 4 plus 4 is 8. So sum x becomes 8. Goes to end. I becomes 4. Sum x is now 8 plus x of 4. The fourth element in matrix or vector x is 8. 8 plus 8 is 16. And I becomes 5. Do I go through the loop now? No. So I stop right there. If I run this, you'll see that sum x is 16. If you'd like, you can say display sum x 16. And that's equal to sum of x. Does the for loop make sense? Is everyone clear so far? Awesome. A couple of points. Here we have sum x plus x of I. We don't have sum x plus I, right? Because I is 1, 2, 3, 4. X of I is 1, 3, 4, 8, right? We want to add all the elements within the vector x. So sum x plus x of I, not I. Here we only had 4 elements, so it was easy to just manually count them. if you have 95 elements, you don't want to manually count 95 elements. So instead of 4 here, I can put what? I want to go all the way to the last element in X. How many? If I want to know how many elements is in X, what is the function that I'm going to use? What is the command? Lengths. Did we discuss lengths before? No. So X has 4 elements, right? We discussed function size. You remember? We discussed function size. That I remember. Size of X is what? 1 by 4, right? We have 1 rows. Size of X is 1 by 4. We have 1 rows and 4 columns. That's size of X. We can also get lengths of X. We have 4 elements in X, so length of X is 4. So instead of here saying from 1 to 4, we can say from 1 to length of X. So now, how many elements is in X? We don't care. It's going to start from the first element, and it's going to go all the way to the very last element. Does it make sense so far? Perfect. So if I run this again, does it change my result? Result is the same, because length of X is again 4. Previously it was from 1 to 4, now it still is from 1 to 4. So that's the summation. Does it make sense? Now, let's see what we have next. The other thing that you can do, if you only are interested in the summation of odd elements, you don't want the summation of, now we have the summation of all elements. If you want the summation of odd elements, what can you do? So first of all, we have 4 elements in here, right? If we want the summation of odd elements, that means element 1, element 3, right? Those are the odd elements. What are the first and the third elements? 1 and 4. Summation of them is 5. Now I will ask you to write a for loop to calculate the summation of odd elements only. You can work with the counter. I starts at 1, but now instead of going all the way to 4, it can go with the step size of 2, right? Because that's the odd elements. 1, step size of 2 becomes 3. Then becomes 5. So if you start at 1 with a step size of 2, go all the way to 4, you get the odd elements only, right? You get 1 and 3. And then you can have the same thing. So why don't you code it very quickly? Just use the step size of 2. We are working on summation of odd elements in X. So instead of going from 1 to 4, we want to have element 1, element 3. X1 plus X3. So in the counter, instead of going from I equal to 1 all the way to 4, you have 1, colon, 2, colon, 4, right? Because then you will jump from 1 to 3, and you want to jump from 3 to 5, but 5 is more than 4, so you stop right there. So it's like this: 4i from 1 with a step size of 2, go all the way to length of x. Sum x is equal to sum x plus x of I. And it starts at 1. So sum x is 0. Sorry, sum x is 0. X of 1 is what? 1. So 0 plus 1 becomes 1. Sum x is now 1. And I now becomes 3. Sum x was 1 plus x of 3 is 4. The third element in x is 4. 1 plus 4 becomes 5. So sum x becomes 5. And then I wants to become 5, but 5 is more than 4, so that stops right there. Sum x is now what? 5. So that's the summation of odd elements. What if you want to calculate the summation of even elements? Start at 2. You cannot start at 0. 0 is not a valid index. There is no zeros element in vector x, right? You have element 1, 2, 3, 4, 5. There is no element 0. This is important. This is very important. There is no 0. There is no negative element. I mean, the element can be negative, but we don't have element of negative 1. We have element 1, we have element 2, we have element 3, we don't have element negative 1. We don't have element negative 5. That's one important point. We don't have real elements. We don't have element 0.5. We have element 1, 2, 3, 4. Element numbers are integers. 1, 2, 3, 4. We are going to get to this in just a second. Write a loop that calculates the summation of even elements in X. Repeat here. So I just copy and paste this here. Instead of starting from 1, I start from 2. That's it. And summation would be 3 plus 8, 11. Which is 11. The other thing that you can do, again, copy and paste the entire thing. Instead of starting from the first element and going all the way to the last, you can start from the last and go back to the first. You can do that. Why do you want to do that? I don't know, but that's something that you can do. So you can start from length of x with a step size of -1, go all the way to the first element. How does this work now? Sum x is 0. It is 0. I becomes length of x, which is 4. Sum x was 0. X of 4 is what? 8. So sum x now becomes 0 plus 8 becomes 8. I becomes 3 now. 8 plus x of 3, which is 4. 8 plus 4, 12. And I becomes 2. 12 plus x of 2, which is 3. 12 plus 3, 15. Sum x becomes 15. I becomes 1. 15 plus 1, x of 1 is 16. So that's another way that you can do this. Does it make sense? So step size can be positive, negative, etc. What's important is step size whatever step size that you use, this counter cannot be negative. X of negative 3, we don't have X of negative 1. We don't have X of 0.5. This here should be an integer. We have X of 1, we have X of 2, we have X of 3, we don't have X of 0.5. We don't have X of 1.5. So instead of negative 1, if I use negative 0.5, I'm gonna get an error. All indices should be positive integers or logical values. In our case, it starts at 4, it's okay. I becomes 3.5, and then X of 3.5, we don't have, non-existent. Does it make sense so far? So that was the for loop. Now let's move to while loop. In the while loop, you have while a statement, do this, end. While this statement is true, continue doing these commands or executing these commands, end. And then you go back. If this statement is true, continue executing these commands, end. If you want to use a while loop to calculate the summation, you would say while. Now the issue is you want to go from the first element to the last element. In for loop we had for I from 1 to 4. In while loop we have a statement, and statement doesn't have a counter. For loop already has a counter. While loop doesn't necessarily have a counter. So we have to create a counter for the while loop. So we say, all right, I want to start with element 1, right, and go all the way to element 4. That's what I want to do. So my counter, and this is again, this is the name of the variable. I call it counter. You can call it J. Well, as a matter of fact, let me call this J. J is equal to 1. While J is less than or equal to lengths of X. You'll see why in just a second. Hang in there. Sum X is equal to sum X plus X of J, and then J becomes J plus 1. This is exactly similar to the previous one. Now we are using a while loop. Let's see what happens. First, we start with the first element. J is equal to 1, right? J, 1 is less than or equal to length of X. Length of X is 4. Yes, so that statement is true. Sum X becomes sum X, which is 0, plus X of 1. So 0 plus 1 becomes 1. Now we want to go to the second element. J becomes J plus 1. And J is now 2. 2 is less than 4, less than or equal to 4. Yes. Sum X, which was 1, is now 1 plus X of 2, which is 3. So 1 plus 3 is 4. J now becomes 3. And 3 is less than or equal to 4? Yes. Sum X becomes 4 plus X of 3, which is 4 again. 4 plus 4, 8. J becomes 4, end. J4 is less than or equal to 4, correct. Sum x, which was 8, plus x of 4, which is 8, becomes 16. J becomes 5, end. 5 is less than or equal to 4? No, stops right there. Does it make sense? The while loop? So if I execute this now, I'm going to get the same response as before. And J is 5, right? As we manually did this loop, we got J equal to 5. And that's what we have there. Does it make sense? The while loop? Do you wanna have a minute to write this while loop and execute it? Sure. Because you don't have an end. So while, so each for needs an end. Each while needs an end. Each if needs an end. So put end. Well, it's still continuing. So you got to use Control C first of all to break the previous one. And now we can do it. So, yeah. Oh, well, okay. Yeah. So if you in the command window, if you start executing the while loop and you don't have an end for it, you'll see that the MATLAB underneath over there, like on the lower left, says continue entering statement. Because while needs an end. If you don't have an end for it, it's expecting an end. So whatever you do is still within that while. If you wanna break a while loop or loop or any executing command, you can hold Control, press C. Control C will break any loop or any execution that's going on.
And how do you can code something correctly? Okay, I always select that we
Yeah.
something which
Yeah, I right click on here
right.
and just click on evaluate selection.
And then it's like
It's the same
doing-
thing as
Okay, thank you.
all right. So that was the while loop. While loops are important in many senses. One thing that while loop can do and for loop cannot is that when you have an iterative statement, you cannot use well, let's put it this way. We can use this approach. So we have a formula to calculate the square root of a number. You give it any number, use that, it will give you the square root of it. How does it work? It will calculate a value. So you start with a value. The function will give you a new value. You put the new value in the function again, it will give you another new value. You put the new value, the new value again, and it will give you a third value. Each time that you replace the new value in, it will keep merging toward your square root. Let me give you an example. So this is the function that we are going to use. Let's say we are looking for a square root of 16, right? We start at any point. We know the square root of 16 is 4, right? I'm going to start at any random value that I like. I start at I start at 8, right? I put 8 into that equation. So I start at 8, half of 8 plus 16 divided by 8. 16 divided by 8, 2. 8 plus 2, 10. Do you start at 8? Yes. 8 plus 2 is 10. Half of 10 is 5, right? That's my new value. Does that make sense? Now, I start at 5. Half of 5 plus 16 divided by 5. 16 divided by 5 is what? 3 point something. 5 plus 3, 8. Half of 8 is 4. 4 plus something. Can someone just calculate that for me? 16 divided by 5 plus 5 times half. I can do it myself very quickly as well. 0.5 times 5 plus 16 divided by 5. So that's 4.1. Then I start at 4.1. Do you see how I'm replacing this in the equation? Does it make sense to everyone? Then here I have 4.1 plus 16 divided by 4.5. So that becomes, I'm going to use R here because R is 4.1 already. So that becomes 4.0012. Then I start at 4.0012 and calculate the new value. That becomes 4.0000. Then I plug in 4.0000. I'll get a 4.0000. I know that for sure. You see, we started at some random value. We merged to square root of x. Square root of x. X was 16. The square root of 16 is what? 4. We started at 8. We merged to 4. Do you think this is good for a while loop? We can say while the difference between the new one and the old one is more than some threshold, repeat this. Put the old one in, get a new one. Right? That's what we did, right? We started at some point. We used that as old one, we got the new one. Then we used the new one as the old one and then got a new one. Then we used the new one as the old one, got a new one. Then that becomes old, then the new one. Then that becomes old, then a new one. Then this becomes old, then a new one. They are merging to one value. So while their difference is more than a threshold, keep doing this. As soon as the difference becomes less than a threshold, it will stop. Does it make sense? Let me give you an example. Let me write this as a while loop, and we can discuss more on there. Clear CLC. We are looking for square root of 16. We need two values. We need R new and R old. Why? Because I'm going to need to calculate their difference, and say if their difference is more than 0.0001, then R old is R new, and R new is, I'm going to explain this in just a second. All right, let's see what happens. Does the example make sense, more or less? Does this example make sense? Do you want me to run another example very quickly? I'm going to explain the code very quickly. But just before we get to the code, does the example make sense? We start at some point, we calculated the new one. Use the new one as the starting point, calculated the new one. Then, see, each time the new one becomes old, and the old gives you another new. Does that make sense? So, in order to write it as a code, what we know for sure is that these values are merging to one value, right? They are merging to one value. So if you keep running this, at some point the two values become the same. So what I say is, while the difference between the two is huge, keep running, because we know that they're going to merge. If they merge to one another, the difference is going to be really small, isn't it? Yeah? So that's what I did here. I want the difference between the new one and the old one to be very small, right? So I say while their difference is more than a certain threshold, that threshold is arbitrary, so you can just put whatever you want. While their difference is more than a threshold, put the new one in the old one and calculate another new. So put the new into the old and calculate another new. Why do I have R new and R old here? Because just before I go to the while loop, I need R new and R old. So I just put two values. It can be any values, doesn't matter.
Can be the same.
Cannot be the same.
No, the same.
If they are the same, then the difference is not going to be more than.
Okay.
So two values, two different values, whatever they are,
One can be smaller and bigger, and then
can be anything. It will merge to the square root. That's the Newton's method to calculate, to estimate the square root. Let me run this. We want the square root of 16, yes.
What did that ABS mean right before the...
ABS is absolute value. All right, I failed to mention that. Absolute value of negative 0.1 is 0.1. Absolute value of 3 is 3.
So that's the way you can have RO be 100 and R new be 1. Like,
Sure,
yeah.
yes. So the reason that we use ABS here, because if their difference is negative 10,
that will change it after.
right? If their difference is negative 10 is not more than 0.00001, right? So negative 10 is still a huge difference. It's in the other direction. So we use absolute value, so the direction is not important. They should merge to one another. They should merge to one point. Does it make sense, more or less? In the back? Everyone? You're good? So now if I run this, you will see that R new is what? 4. because they should merge to the square root. I started with 10 and 8 and it merged to 4. Now let me start with 20 and 35. It will still merge to 4. So no matter where you start, because of this iterative process, you'll merge to the square root. The only difference is if you start from somewhere closer to the square root, it takes lower number of iterations. If you start farther away, it will take more iterations. Now, in order to know how many iterations it takes, I can put a counter, right? Counter is equal to 0 because we haven't done anything yet. Counter is 0. As soon as one iteration is gone, counter becomes equal to counter plus 1, right? So each time counter goes up. So here counter is 0, counter is 1, counter is 2, counter is 3, counter is 4, counter is 5. Does that make sense? So if I evaluate this, it will tell me how many iterations it would take. So it merged to 4 with 7 iterations. If I start at 8 and 5, it would take 5 iterations. It was closer. You start at 4 and 5, it's probably even lower number. With 1 iteration, it merged to the square root. Does it make sense? The while loop and the counter? The problem with the while loop is that if that statement is always true, it will keep running. So if you say while 5 is more than 3, keep replacing R new and R old. It will do it forever because 5 is always more than 3. Does it make sense? So if that statement doesn't become false at any point, the while loop will keep running. If you want, you can use that counter within your statement, saying that while, let's say I don't want my while loop to run more than 5 times. I could say while ABS of R new minus R old is more than 0.0001 and counter is less than or equal to 5, keep running. Then as soon as, let me put it here.
So what exactly does the counter do?
Counter will count how many times you iterated. So each time that you go through this, counter will increase once by 1. So what we are doing here, we are saying while the difference between these two is more than 0.0001 and counter is less than or equal to 5. So what happens is that if this becomes true, if any of them becomes false, this will stop, right? Because if this is true, if this is false, and true and false is false, it will stop. With the starting point of 4 and 5, it wouldn't really matter because counter is 1, it will merge to 4. If we start at 54 and 59, then what happens, if I run this again, R new and R old is 4.006. They are not 4 anymore. Why? Because we only allowed for 5 iterations. The moment that counter becomes 6, it will not run anymore. Does it make sense? The for loop and while loops, they are very important, and at the same time they are kind of boring as well. So bear with me, we are going to get to more interesting concepts. So that's the for loop and while loops. You don't have to worry about the break and return. Pre-allocate memory, it's not important at this point. There are 2 important concepts that I'll cover for the rest of this session. So we are out of the for loop and while loop now. Let me define X. I use CLC and clear, everything is gone. I define X as square root of, starting from 0 with the subsize of 4, go all the way to 20. I just evaluate this. I want to find those elements in X that are integers. Integers are 0, 2, and 4, right? Which elements in X they are? They are element 1, element 2, and element 5, right? So X of 1, 2, and 5 are the integer values. X of 1, 2, and 5. I'm calling elements 1, 2, and 5. So 1, 2, and 5 are within a vector. X of 1, 2, and 5 are 0, 2, and 4. Those are the integer values. Since that's a square root of values with a subset of 4, square root of 4 is what? Square root of 4 is 2. That means that if we want to find integers, if we divide them by 2, the remainder of that division is 0. If we divide them by 2, so 0 divided by 2, 0. Remainder 0. 2 divided by 2, 1. Remainder 0. 2.8 divided by 2, 1 point something, right? So that point something means the remainder is 0.8284. Then 3.4 divided by 2 is 1 point something. 2 out of that is complete. 1.4641 is remainder. 4 divided by 2, 2. Remainder 0. 4.47 divided by 2, 2 point something. That point something means remainder is 4.721. Does that make sense so far? So we can get remainder of X with 2 using the function in MATLAB. So remainder is a function, REM, X comma 2. If I do this, X is 0, remainder of X divided by 0, X is 0, remainder of 0 divided by 2 is 0. Remainder of 2 divided by 2 is 0. Remainder of 2.8 divided by 2 is 0.8. Remainder of 3.4 divided by 2 is 1.4. Remainder of 4 divided by 2 is 0. Remainder of 4.4 divided by 2 is 0.4. So does the remainder make sense more or less? Perfect. I see people are bored and yeah. Bear with me. These sessions will pass and we are gonna have a more fun classroom, I promise, in 2 weeks. That's promising, isn't it? It's only 2 weeks. All right. You know what? I'm gonna stop right here with the remainder. We are not gonna go through with that. One last thing, and you're out of here, is the inline functions. The concept of inline function. We talked about the functions, right? We talked about the built-in functions, and we talked about the functions that we write, right? So it starts with a function. We have outputs, name of the function, inputs, right? Remember those functions? Function? You don't remember? You don't want to remember? There is another function. There are a couple of more other functions, but for now we are going to focus only on inline functions. Inline function are functions that are simpler in a sense. You don't have to open up a script, you don't have to write function, you don't have to put names, you don't have to put inputs, etc. If you want to evaluate a function like x squared plus log of x, you don't want to write this as a function, like function equal to output is equal, like y equal to name of the function parenthesis x. Instead, you can use inline functions. How does it work? It's like this. y1 equal to inline apostrophe x squared. I put a dot there. Why do I put a dot here? Why do I put x dot squared? So all elements are raised to the power of 2. Element by element. Plus log of x. Now, if I evaluate this, you will see that you have a function called y1. So the name of your function is now y1. And that's an inline function. Anytime that you want to evaluate that function, you'd say y1 of 2 is equal to 4.6. Why? Because that is 2 to the power of 2 plus log of 2. So y1 is now a function. You can give it an input, get an output from it. You can give it a vector, input is a vector, output is going to be a vector. Because if you have y1 of 2 and 4, then you have 2 squared plus log of 2, and then you have 4 squared plus log of 4. Question? Yes. Have you defined it already? Have you defined this y1 equal to inline?
Yeah, I did exactly what you did. Why?
Have you evaluated it as well?
Yeah, I defined it.
Yeah, so
Makes it do
you
all
haven't-
iterations of that.
So
So if you didn't have that dot, I don't know, it might just not work. But regardless, that dot is required to do like the 2 and the 4. It's required to do each iteration. The only thing is, I don't understand why you have a dot there.
So in the
In the log.
Alright, I'm going to stop right here. Please watch homework videos. week 2 and week 3, both of them are uploaded. Watch them, they are very important. We are gonna have a quiz on Friday. And that's for the record, it's being recorded, so I have to keep my promise now.